Something that's also important to know when we talk about learning to use Keras is the difference between the sequential API that Keras offers and the functional API that it offers. It is very important that we understand the difference between these two and use them appropriately. Here's an example. Say, for example, I have a data set that looks like this. Here's my input columns, first column, second column, third column, all the way to the last column. And here's my output labels, Y, as you can see. We want to design a neural network model that takes all of these inputs, and then we have 8 neurons in the first layer, and then 4 neurons in the second layer, and 1 neuron in the last layer. Say, for example, this is sigmoid activation, which predicts a score between 0 and 1, and then loss is calculated with the actual output. Finally, we want to learn the weights of this neural network model so it can predict these output labels accurately, right? Now, one of the easy ways we can do this is to write a code that looks like this. Sequential model equals sequential, and then add a dense layer with 8 neurons in it, and the input shape is my number of input columns, and say my activation is ReLU. Add another layer using this add feature in sequential model. Finally, add another layer with 1 neuron, activation is sigmoid, and I can print the model summary and I'll get certain number of parameters. Now this is, in a way, this way of creating a model is simpler and easier. It's simple and it's easy. It simply tells us that we have initially a sequential model. I add a dense layer with 8 neurons, and then I add another dense layer with 4 neurons, and then dense layer with 1 neuron, and so on, creating a stack of layers. Turns out that this way of creating a model is helpful most of the time, but when we are designing slightly more complex models, for example, residual neural networks, then this way of creating model, the sequential way of creating model, does not work. It fails because it does not allow you to go back from D4 to D8 or this D1 to D8, etc. So alternatively, we can create a similar model with same number of parameters, actually same model with same number of parameters using a different technique, and this is the functional API. Functional API or functional way of creating models. So instead of doing sequential model equals sequential, I do layer 1 as input. So I create in my directed acyclic graph, I have my input layer created, and then layer 2 is a dense layer with 8 neurons, activation ReLU, that receives layer 1 as input. So this goes as input to my next layer, D8. And then my layer 3 is another dense layer which receives layer 2 as input. So this is my layer 1, this is my layer 2, and then we have D3 which receives input from layer 2, and this becomes my layer 3. And then finally, we have another layer, dense 1, with activation sigmoid that accepts layer 3 as input and gives me the output. So D3 goes to output, and this is my layer 4, we could say. And then once we do this, we can create a functional model by defining my model such that my model's inputs is layer 1, here's my input, and the model's outputs is the output that comes out over here. So this will be my output, this will be my input, layer 1 is my input, and then I have created a model using those inputs and outputs. And then if I do functional model.summary, I will get the exact same model that I would get from the sequential model. Once again, If you, and now this, once again, if you want to always stick to one thing, I would suggest that you stick to the functional way of creating models, because this way you can design more complicated networks like residual neural networks when needed. Now, this style of creating neurons is slightly complex and maybe slightly difficult because you have to keep track of previous layers and next layers. And if you accidentally, instead of layer 2 here, say you wrote layer 3, then your whole graph could be disconnected. But it is powerful. It is powerful. It's powerful because we can create complex neural network architectures such as residual neural networks.